Okay, as we continue with our B2 handout, this next graph that comes up in questions 9 through, 16, is a little strange. What's happening in this graph? You see this dotted line, okay? This dotted line, which occurs at x equals -3, this dotted line has a name. This line is referred to as an asymptote. And in this particular case, it goes up and down, so it's a vertical asymptote, okay? The line x equals -3 is a vertical asymptote to our graph. And what that means is there's a break in the graph there. And what you can tell by what the graph is doing, it's getting closer and closer to that line, but it never touches it or crosses it, okay? So, -3 is virtually being left out as an x value. So this ties into question 9. What is the domain of the graph? Well, normally if I scan from left to right, you can tell this graph normally would pick up, all real numbers. From -infinity, and the graph continues over to +infinity. This is dropping, but it's also going to the right. So my graph would normally be all real numbers for the domain, except we have to leave out the number -3 because there's a vertical asymptote there. So the way you write the domain in interval notation is you skip around -3. You go from -infinity to -3 with a paren union -3 to infinity. So that's just a clever way of leaving out the number -3. It skips the domain, okay? It is not part of my domain, and that's how you write it, okay? And that occurs when you have vertical asymptotes, and this is an example of one. Range, you scan from bottom to top. Well, this doesn't affect my range. This is an x value where this asymptote is occurring. My range in this case is going to be, okay, this arrow goes down, so we're coming up, we're coming from bottom to top. We're just scanning. We're coming from -infinity, and we just keep going up because these arrows tell me that. So my range is no different. My range, the answer to question 10 would be -infinity. I'm trying to hold my paper still here. -infinity to +infinity. Okay? All reals. So my range is -infinity to +infinity. Question number 11 wants to know what the x-intercepts are. Well, the x-intercepts are the ordered pairs where my graph touches the x-axis. So, let's see. That, where I just put a dot, is the number -1, but as an ordered pair, it would be -1, 0. And you always write the x-intercept as an ordered pair. That's, by definition, what an intercept means. And there's another intercept. Let's see, it's right there. It's where x is 3. So we write that as the ordered pair 3, 0. And there's one more intercept, and that's right there. And let's see, that's 3, 4, that's the number 6. So we would write that as the ordered pair 6, 0. Okay? So there are 3 times this graph touches the x-axis. At -1, so we write that -1, 0. At 3, which is 3, 0. And at 6, which we write as 6, 0. Question 12. For what x value does g of x equal 0? Now, we virtually just answered that in number 11, but they're asking for it differently. This question says, what are the x values where y is 0? Well, in every one of these ordered pairs, y is 0. So all they're asking, though, in question number 12 is, for what x values does that happen? So the answer would just be x equals -1, x equals 3, x equals 6. Okay? So virtually questions 11 and 12 are turning our eyes toward the same place. They're turning our eyes toward where the graph crosses the x-axis, because after all, where is y equals 0? That's going to occur on the x-axis. But question number 11 specifically says what are the x-intercepts. Those have to be written as ordered pairs. And question number 12 specifically says, for what values of x does g of x equal 0? Those are not ordered pairs, those are specific real number values. Okay? So, we're looking in the same spot, we're just answering them differently. It's a matter of semantics, and you need to get used to the fact that in higher level algebra, intercepts should be written as ordered pairs. Okay? And we'll pick up the remaining 4 questions on the next video.